Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 391, minimize Manhattan distances. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. This one I actually struggled with a lot, and it's the thing that really destroyed me. 26 minutes is how long I spent. To be honest, I spent a long time on this one because I was thinking about it. I got fooled by the red herring, which is what they want you to do. And I just kind of forgot about it. I think one thing that I would say though is that they don't really define Manhattan distance, which is kind of crappy of them, to be frank. I mean, I didn't need to Google it, but I think people could have Googled it, and it's just like a little bit weird, right? And also, I think as a result, from what I heard, you could actually Google this problem, and it'll give you like 80% of the answer, which I didn't do, so I don't know. But which obviously, because otherwise maybe I wouldn't take 26 minutes. Maybe I need to do that. But no. For me, it's focused on the learning, so it's fine. It's just a sad end of my rating 3000. No, but yeah. So basically, Manhattan distance, right? So what is the Manhattan distance? Let's examine this real quick. And this is, just to be clear, this is not what I did. I spent 26 minutes. Maybe a good amount of time on it was, to be honest, I was trying to come up with computational geometry solutions, and that's basically what I was trying to do. Maybe I should have, I don't know why this is a 7-pointer. Maybe according to these things it's harder or easier, but I think I was kind of like meta fooled, if you will. Like I was thinking like, oh, it's 7, it must be a harder thing. So I was thinking about like computational geometry or some sort of processing thing like KD tree and stuff like that, and sweep line. So I was kind of thinking along those lines for way too long, to be frank. There's not much to go over there because I didn't really get it that far, at least computationally wise, just because it was too expensive to kind of do anything. But yeah, but okay. So, but the right way to do it is just actually just thinking about it. And to be honest, I think a similar problem is on like a Q3 in a previous contest, I think, but don't hold me on that. A lot of problems are similar to me, so I don't know. But yeah, so basically the idea is that, okay, you have some x sub j, present that's x sub j, so then you have minus some x sub I plus y sub j minus y sub I, right? So let's just say that we don't delete any point yet, right? If we don't delete any point, then and basically we're just trying to first calculate this for the input. We're trying to calculate this formula for the input, right? And it turns out that taking away the max first, there are really 4 possibilities, right? There is because this is the absolute value, just to be clear, right? So let me rewrite this real quick so that it's easier to read at home. Maybe I don't know if that's true, right? But let me rewrite it anyway. Right, so now you have this, and then now, so what does this mean? This means that it turns out, and I actually have trouble coming up with this, to be honest, even after I realized this, because I was just, this is why I say, like, have a notebook and write things out, and I just kind of, some days I just visualize things a little bit incorrectly in my head, and yeah. So it's going to be this plus y sub j minus y sub I, and this is kind of, this is assuming that y sub j is greater than x sub I, and y sub j is greater than y sub I. It's either this or this, right? Because this is, well, okay, let's just keep this j and I for it. Because this is basically what this part is saying, is that x sub I is bigger than x sub j, so you have this number, right? That's pretty much it. So you revert them because that's the bigger number, so it should go in front. Or x sub j plus y sub I minus y sub j, or x sub j minus x sub I plus y sub I minus y sub j. And this one is just the same as this one, except for if y sub I is bigger than y sub j, and here is just if both x sub j is bigger than x sub I and y sub I is bigger than y sub j, right? So these are the 4 things, and to be honest, during the contest, it took me a long time to convince myself that this is sufficient. and I kind of YOLO'd on it a little bit during the contest because I don't know. I think I just wasn't able to think clearly about it. Some days you're just not 100%. It is what it is, sadly. But yeah. So basically, it's for the max of these 4 things, and so the reason why I couldn't figure out why this is the case is because I was like, oh, but I don't know. I don't know why I thought this is not a correct thinking, but I would say that I was just thinking that it could give you like a false positive in some weird way. So I didn't really think it through. But if you think it through, you'll notice that this max is correct because let's say let's plug in some numbers, right? And we could just do one dimension anyway. So let's just say we're trying to say that x sub j is you go to max of x sub j minus x sub I, or x sub I minus x sub j. And the reason is because if you have let's say 5 and 10, well, it's just you go to max of, so this would give you 5, or well, this would give you -5 and the other would give you 5, and you want the max of them. The reason why it's kind of sad. And the reason why I wasn't able to think about this during the contest was that I just thought there were some false positives, but for some reason I don't know. I would add an important point for those people who are studying at home and you wonder, and you talk about practice. I talk about practice a lot, and why do I keep on talking about practice, right? The thing is that I almost want to say a lot of people who have seen this, because this thing happens not like a lot of times, but enough times that a lot of people know it like this, right? But for me, I practice. I mean, I only practice on daily videos. I don't really practice, and I only practice during contests. So everything you see on my YouTube videos is everything that you see me do. I mean, I do, like, in terms of algorithms, because I do random programming here and there, but in terms of algorithms, that's how you see it. But what I mean is that when I talk about practice and how people are able to get it so fast, well, to be short and to be real, I had to prove this during the contest, and it took a while. But people who have done it and seen it, people who have done it and seen it, they just get right to it, right? And this saves them 20 minutes. So now that you have this, then what happens? Okay, let's move this for a second. Now that we have this, what happens? Well, now we can recollect the i's and the j, right? So what does this equal to? So this is equal to the max of xj plus yj minus xi minus yi, or minus xj plus yj, right? Plus xi minus yi, right? I'm doing this live, sorry, but yeah. So here we have. Why did I put the j's in front? That's weird. But okay, fine. Minus xj plus, minus yj plus xi minus plus yi. I'm not writing this optimally yet intentionally, so hang on. But yeah, but I'm also just writing it very dumbly, so I don't know. This is minus xi plus yi, right? So you have this formula, which is kind of ugly, but we'll rewrite it also again very quickly, which is to put the signs together. So then you have xj plus yj minus, put them in parentheses, xi plus yi, right? And then now you have you have I don't know why I write it this way, but okay, fine. I don't know which way is better. But yeah, this plus xi minus yi, right? And I'm just doing line by line. Plus yj plus xi plus yi, right? And then lastly, you have xj minus yj minus xi minus yi, right? Okay. And then now, well, there are two things that come to, you know, now there are two things, right? One is that you notice that we collected the i's together and the j's together, right? What does that mean? That means that now, if we do a linear scan, we can cache these all together and put them somewhere. But also, now let's get back to the original. Okay, so this is just for two numbers, right? And then we're trying to figure out the entire max of. What is that beep? Maybe it's my smoke alarm. Now you're trying to max this for all the numbers, i's and j's, right? And then here, now you can see that. Yeah. You can see that there are really two components, right? So you have, so for the previous number, you have this one, right, which is the sum of the coordinates, and you have the subtraction, right? What happens? So now you're trying to minimize and maximize these things, and then yeah. And you can actually even rewrite this a little bit if you want. Maybe this is, I mean, I just wanted to put the i's and the j's a little bit together so that you could see it. But if you want to rewrite it another way, this actually looks something like this, right? Okay, actually, this one is just copy and paste. So this one's fine. But then here, you know, the negatives, right? So you have something like this. So you can actually switch the signs. Right, and then now you have this. An extra space. This one again, we also switch the signs. Right, or you know, move the plus to the beginning, and here we have this, right? And then now what happens? The extra space is bugging me. Sorry. Now what happens, right? Now you have the difference between these two things. So then what else happens, right? Well, what happens is that let's say we're trying to maximize all of so okay, right? Let me say it. Let me start from the beginning saying this, right? So basically this formula is equal to this formula, right? And then now we're trying to maximize or to find the max of this, right? So we're trying to max this over all the input, right? And which you can kind of, now that you think about it, and this of course is equal to max of all these max. So this. Just to be clear, there are two layers of max, right? But now that we have this, what you can also notice is that, well, max of max is just going to be max, so you can actually remove the max, even though I know that I intentionally did two of them on purpose, but then now we can just remove one of them to kind of, but in an aggregated kind of way. So you can say this is for all i's and j's, right? So yeah. But the idea here is that now, because max are kind of independent in a way, then now we can max each of these things independently, right? So what this looks like is, maybe something like this. Right? I mean, the notation's a little bit yucky, but hope you bear with me, right? So then now you have max of all this instead, right? And then now it becomes a little bit easier because, okay, let's do this one. Now we can do this one at a time. I think I'm missing a parens, but okay, fine. This is not real code, right? But yeah, but then now you can do this one at a time, right? So let's say we only focus on this part. Let me put it on the bottom, right? Let's just say we focus on this part, right? Let's just say we're trying to max this. What happens? Well, we maximize this when this number is the biggest. So so x sub j plus y sub j is the max, is the biggest, and and we have to find some other where this is the smallest, right? And that's basically the idea. And we also do the same for this one, right? And you can do this like, you could calculate all these for the numbers and then just sort them, for example, is one idea. But yeah. So then now for this one, we're trying to find x sub I minus y sub I is the biggest, and and so forth. So I'm not going to do all these, the other two, because you can kind of see that we're just trying to maximize this and this. And it turns out you can see that we do actually reuse this, and the j's and the i's don't matter, right? Because we're looping through everything. So all we have to do, all it comes down to is that so if we store the biggest x sub I plus y sub I and the smallest x sub I plus y sub I, and the biggest x sub I minus y sub I and the smallest x sub I minus y sub I, then that's it, right? And then we just calculate all this brute force out. If you want to do it, there's only 4 combinations. Then we can get the maximum distance. Maximal distance? Yeah, I think it's actually maximal distance. But all right. So then this gets you the maximal distance if you get the biggest x and biggest y, the biggest sum and the biggest delta, right? All right. Now, okay, so that's only half the problem, right? Or whatever percentage it is, because yeah. So that's only half the problem because you have to remove exactly 1 point. So this is the other key observation about this problem, which I figure out I don't think it's a crazy concept. I figure out pretty okay. I don't know if it's a hard one. Let me know in the comments if that's the part you're missing. But the idea here is that, okay, let's say we figure out, the biggest ones that are in here or whatever. Then now we have to, basically we figure out which 2 points gives you the biggest delta, right? The biggest Manhattan distance. So then now, the only way to improve it is by removing one of those points, right? Because if you remove any other point, those 2 points still exist. So those 2 points will still give you the biggest Manhattan distance. So then now you just brute force removing the 2 points, and as long as you do things fast enough, that's only 2 points, and that should be good. And that's basically our idea, and that's how people get it so quickly. But I took a long time because I went on a fishing expedition over here on some computational geometry. And I was just honestly staring. I didn't realize about. I think I missed. As I said, I didn't realize that this part is true because I thought that for some reason in my head, like I thought that you have like double negatives and it gives you like a false answer or something. I don't know why. Lack of practice, lack of sleep. I don't know. Whatever, right? So yeah. So let's go over the code. So here, first. I do it. So the way that I have it, I don't even need the sort, to be honest. This is not a sorting part. I always put a sort just because you never know, but you actually don't need the sort, as you can see. I'll give it a submit. But that'd be funny if it just gives me a wrong answer. But yeah, just to be clear, because I don't want people to have a misconception. But but yeah, basically first I calculate this thing, and I have this function to be reused. I have an index that I can skip. If it's -1, I don't skip anything. So that's basically what it's doing. Yeah, so I keep track of the min, and this is min max index indexes of the sums, and this is min max indexes of the differences, or I call it deltas, I don't know why, which is why I had a D and min and max, and the C is a little bit weird. I C for me is an abbreviation for consider. So sometimes it is an abbreviation for caring. I don't know. It is just what it is. That's how I call these notations. But yeah. So here, if I go skip, we just skipped processing that one. That's how I handled reusing code. This is the sum part. This is the delta part, and this is just keeping track of the min. And if this is the min, we keep track of the index because that's the index that we can care about. Yeah, and the max as well. So we keep track of the indexes for the min and the max, and the min and the max for the delta part. And then here, I return everything. It is very yucky, but I return all the things that we calculated and also the answer for this part, so that we can use it later. So then this is just taking the same variables. They're kind of yucky. My apologies, but yeah. And then now I calculate. Okay, this is the sum. If the answers from the sum part, or the answers from the delta part, right? So whatever's bigger is going to be your answer. So I just take that part, right? So this is basically saying, either it is, if the answer comes from this part or this part versus this part or this part, which is the delta of the differences instead, right? So yeah, so that's basically the idea. And if we're taking the max, then we remove the index of the max. Otherwise, we do the delta index. Honestly, I think you can also just do it 4 times. You don't need this thing. But yeah, if you don't want to think about this, you don't really need to. You can just do it 4 times and just calculate it for all the indexes that we have. And one of them will give you a better answer. And that's the one that you choose, right? So yeah. But this is just skipping the... we're skipping the index that we care about or consider, which is one of the things that we keep track of here, right? And then 0, the 0th index is just the actual answer. So that's why I just return the min of these, and then we just calculate it. This function is linear time, right? So yeah, we do this linear function 3 times, 5 times if you want to be lazy about proving this, which maybe I should have, to be honest. So yeah, that's all I have for this one. It's kind of I don't know. I feel like a lot of people got this one before me. So I don't know. For me, it's a tricky problem, mostly because I had to reprove some stuff and I wasn't convinced about the proofs in my head. That's where, like I said, when you practice enough, this should be maybe not as fast as some of the top people, but this should be like a pretty reasonable problem to solve. And I showed you all the exhaustive math. Hopefully that's useful. But yeah, let me know what you think. Let me know how you did in this problem, this contest, everything in between. But yeah, I don't know. Stay good. Yeah, I would also say that if you didn't do that well on this one, keeping in mind that, like I said, most of this problem apparently is Googleable. I wish I knew that before. And yeah, because it's Googleable, don't feel so bad. It's just a silly problem. Right? At least for rankings, right? Focus on the learning. The ratings will come, whether it's Googleable or not. Anyway, yeah, that's all I have for this one. You could watch me solve it live. It's just me mumbling a lot about different ideas, and I couldn't get it out. And I had to really put it on paper to really prove to myself after the contest that this is correct. So yeah, but yeah, you could watch me solve it live in contest now. Okay, yeah. People already got this? What the? How people already already finished stuff so quickly. Minimum parser value for the maximum value. Okay, so we remove one in which the maximum distance. What do we remove? Something on the comics. Oh no, it's Manhattan distance, right? How do people really solve this? Alright, well. Can I binary search? Okay, how do we figure out the maximum distance anyway? Even without the removal. So we sort, right? We sort with X. Scan lining. Scan lining. 4, 4, we go, okay, well, this is 1 plus 6, which is, I don't know if that makes sense. And so we have 4, 1. And then now 5, and then this will be 2, but this is also, you know. I don't know that I even know how to calculate this. People know this, but I don't. How do I even get the maximum distance? Even on the diagonal, it'll be like can we remove just like you remove all the points on the diagonal, it wouldn't really quite work with it. Well, people already got it. Like a lot of people. Can I do a minimum spanning tree? No, minimum spanning tree doesn't show this path. We have no idea. Computational geometry. I should have my paper ready. So okay. Okay, still thinking about this. They should really talk about Manhattan distance, but okay, so y sub x sub I minus x sub previous plus y sub I minus y sub previous, and we're trying to minimize this. Okay, that's probably the trick. Is that okay? You have the previous, so then you reduce it all to we have all the numbers that are smaller than it and all the numbers that are bigger than it. Right? Even just getting that is tricky. But so in trying to okay, so the maximum distance is going to be something that maximizes this formula. So that means that how do I do the removal point part? People are getting it though. People already done, I guess so. Oh, I guess it doesn't say. How am I 265th? It's probably just really fast. So okay, if we're trying to minimize them, okay, we're trying to maximize this. And we're trying to find the max. So what is this number, right? So this number is going to be 4 quadrants, kind of. Okay, so we sort, then all the x, so this would be positive. So then that means that we only have this, so we only have 2 cases. Is that true though? Okay, so then now So if you keep track of all the things, well, we have to remove something that's on this 18, I suppose. So we can kind of click into that. I guess once we find the 2 points, we have to remove one of them by definition. Yeah, and then that's it, right? So we just have to find how to figure this out. And if we sweep, then you have negative x. How do I figure that out? Oh, I guess it doesn't matter because it's negative x. The y signs. No, it matters because it depends on which one's which. So if I do a sweep, can't just blindly add that part, can you? How do I do this absolute? Okay, so I binary search on the y. Maintain a suffix max and suffix min. With a no, I'm not gonna sig tree. And this is not looking great. Oh, Josh. Something on the boundary. Wow, a lot of people are getting this one, so I'm kind of getting tanked. But okay, let's just try to figure this out. Okay, and then now we have to return the max of the but I haven't deleted the 1 point yet. I just want to see if this works. Maybe not. And let's have some typo of it. 27 doesn't seem right. Oh, what? No, I'm just dumb. Okay, 18 and 2. Okay, so we got this part. And now we're trying to figure out which point to remove, right? And we remove if okay, maybe we have a the other way around. Writing this way awkwardly because you have to consider the other point. What is the other point? I guess it's the other point. It's the other point. But yeah. Oh my god. Made the same mistake twice, lucky I got. Okay, right? And then now. No, I mean. Else. And then we try running all this thing again. Ridiculous. I know this isn't right yet, but I just want to see. Oh. Well, that's unfortunate. Max or min, I forget. It's max. Okay, and now we have to remove one of these by using skip. Right. Actually, this already does it, so I could skip this. This is yucky. Okay, well, I was worried that that was the case. Fudge. Just wasting a minute just retyping this. I don't know what's faster. That's unfortunate. Oh, I still didn't do the skip. And also I didn't do, oh, I did do it, okay. YOLO. I didn't know how to do that one though. Kind of took a while. This people really knew how to do that one. I mean, I'm really far behind. How many people? 200 people got it? That's crazy. I wasn't sure. The thing is that I couldn't prove that this was right. I had in my notepad looking at it, but well, that was a disaster. People are very fast though. So right now I'm just trying to think how could I have done faster. The very slow result. I think this is a the one without the removing a point. I think it's a known problem though. It's just that I couldn't really remember it exactly. And I had to kind of rederive everything, which is why it was so slow. The sorting is not necessary, but so actually, I guess it changed the complex a little bit, but it's fine. Yeah. I don't know. How could I have done this faster? I'm like staring at it, but I just couldn't really figure out how to optimize for it. I was hoping to export one more thing, but I didn't, so. But I just couldn't get it fast enough, I suppose. I wish they also defined the Manhattan distance, but besides the point. I couldn't prove this. That's why I was. Or like, I think with this one, I just had trouble proving that. I just had trouble proving that, like, it doesn't make a mistake on this part. This is the only part that I kind of couldn't really figure out how to handle. And I was just kind of YOLO guessing. Like, how do you able to kind of just take both of these and think that the maximum of that is fine? Right. So we have min. I don't know. I'll probably take a break. Yeah. Oh well, end of 3000, I guess. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between in the comments. Yeah, stay good, stay healthy, to good mental health. Have a great weekend, everybody. I'll see you later. Take care. Bye bye.